Hello, how's it going? Apologies if my voice sounds weird. I came down with a crazy sickness recently, so we'll just see if I can get through this without coughing my lungs out. But anyway, today we're looking at creating the graphics pipeline. Recommended viewing for this would be the previous video in the series where I sort of work out on paper sort of a big picture view of the graphics pipeline and all the components that go into it, because there's a lot of coding today, and if you run through that, hopefully it'll all make a lot more sense in this video. Okay, so just while I've got this shaders file open, here we have a function which will read a file and basically get the string of characters, the source code. Let's make another function which will actually call this and create the actual shader modules. So let's just go ahead and write the prototype. So a compiled piece of shader code is what's called a shader module. The first thing we'll do is we'll go ahead and we'll read that file and call the function above. Okay, we'll then create a shader module create info struct, populate it as required, and then attempt to create the shader module. So as we're probably used to, we can read here the arguments which we take for our module creation. All of these have default values, except I guess for the module info. Also another refresher, at this point here where we set these flags, this is essentially setting the S-type and P-next from the Vulkan C API, and it's essentially kind of zeroing out the structure is what it's called. So it's just making sure that we have sensible values set for the parameters that we're not using, and we don't have to go and retype every single S-type, for instance. Okay, there we have it. So we will use that later, but just while I had that file open, I wanted to work with that. So we're going to be doing the pipeline stuff, so let's get rid of everything except for maybe the engine. And we'll also add a file to hold the, where is this? We'll also add a file to hold the pipeline code. Okay, so what we want to do is we want to sort of create a pipeline, and in order to do that, we're going to have a bunch of parameters that we take in for pipeline creation and a bunch of things that we send out once pipeline's created. We're not just going to create a pipeline. For now, we'll create structs to hold these, and we'll just leave these as empty and populate them as needed. So we'll have a struct, we'll call this graphics pipeline in bundle, and we'll have an out bundle as well. And then we'll make the functions. We go so there we have it. We take that structure, we read anything we need to read, we do our work, we put out some output. So let's go ahead and set this up. We'll go, oh, Okay, then we'll pop over to the engine and we'll say, right, what do we have here? We're going to have device setup and also pipeline setup. Additionally, we're going to have a bunch of pipeline related variables. So we'll just put this here for now. Great, then we'll go to the source code and we'll call this and define the function. Oh, yeah, of course, we also need to include our new pipeline file. Okay, so where was I? Okay, so it's not very exciting at the moment, but we've got the basic skeleton. We can keep running this function as many times as we want, and it'll work, at least. It's a good idea to try that just to make sure that everything's doing what we expect. Yep, and it is. There's a lot of printing, but that's fine. We've got that all. Okay, great. So let's jump into the pipeline function and actually step through the pipeline creation one step at a time. First, I'm going to make a bunch of variables which will sort of be populating as we go. So I'm going to declare the pipeline create info at the start, and then as I step through the stages of pipeline creation, I'll be setting individual parts of the pipeline info, then we'll build it in the end. Okay, so yeah, as we can see here, we're going to be fleshing this out as we go. And as we go through the stages, we're also going to be filling in the shader stages. The first step is we're going to look at vertex input. Remember, vertex input is essentially saying what are the buffers and attributes that are being thrown at us. Okay, so at this stage we're hard coding our buffers, so we're not actually sending any data in. So we will have, oh, doubled that up, all right. What is it? It's vertex binding description count. Yep, zero vertices are being bound, and trivially, zero attributes are being passed in. We then register this with the pipeline info. The next stage is input assembly. So given that the input has come in, the next question is, what are we going to do with it? What sort of shapes are we going to, how are we going to partition this into shapes and so on? Okay, so topology is the type of shape that we're drawing. We can see all of these options. In this case, I'm going to go with triangle lists. Just felt like I missed something, but no, that's fine. Okay. Okay, so we've got that good to go. The next step is the vertex shader. So for this, we're going to use that function which we defined before. So now, see, we're going to have to pass in some info. So we can look back at our struct and say, okay, well, we need a few things. We need the device. We need the file path. And yeah, that should be fine for now. We're taking in debug as a parameter here, so that's fine. Okay, so where was I? So create module takes the file name, so we'll get the device and the debug mode. Alright, so we have compiled the module, but there's a bunch of other things we need to specify. For instance, we need to specify what sort of shader we've actually made. We need to point to the code which is compiled, and we also need to specify the main entry point. Most times it'll just be main. We can get creative if we like. It's a good idea to run this right now just to check that the shader is actually compiling, and don't forget we'll need to specify a bunch of things here now. Where were we? So we got shaders, and then it was vertex.spv. Okay, let's try that. Okay, seems to work. Now we're getting a validation error, and that is essentially saying, where are we? The shader module has not been destroyed. Yep, okay, that makes sense. Just as a sanity check, what we can do is we can pass in an invalid name and check that it is actually reading it. So that's a bit strange. It could potentially be something to look at. Yeah, it's fine. It's probably fine. It was working before. Okay, so where was I? I sidetracked myself. It is complaining that we haven't destroyed the shader module. So it's a good idea, after everything's set up, to destroy the shader module. So we'll go shader module we're going to destroy is that vertex shader, and everything else should be fine. Let's try that. And now it's working with no error. Okay. So where was I? We've got that all set up. The next stage is the viewport and scissor for the like the screen visibility tests. Okay, so now things get a little different because we want to set up from 0, 0 across the whole screen. But then the question is, how big is the screen? So one way we can do that, if we don't want to hard code, is simply pass this in. So we go, I think it's an extent 2D. So we're going to pass in how big is everything. So we double check here. Yep, swap chain extent is an extent 2D. Okay. We can then access that info. So we'll go down here and say width is okay, great. So we've got the viewport well defined. Now let's look at the scissor. Okay, great. So once the viewport and scissor are both defined, we can use those to create a pipeline viewport state, which is really just a fancy or not fancy way of saying wrapping everything into one structure. Okay, excellent. We've defined everything there. We've passed that all through. That's great. The next step is the rasterizer. Okay, so here you can see we're setting a bunch of parameters for general rasterization. Maybe a few things to note. Depth clamp is saying, hey, when we get fragments which are outside of our accepted range of 0 to 1 for the depth, should we keep the fragments and simply clamp their depth to the min-max? We don't want to do that, we just want to discard them. And then this bit, rasterizer discard enable. If it's set to true, the rasterizer will basically throw all of its output away and it won't produce any colors. I have no idea why someone would want to use that because, well, compute shaders exist, but anyway, it's Vulkan. It's flexible, sometimes too flexible. So the next stage is the fragment shader. So what we can do is we can grab the vertex shader from before and specify that down here. And we're going to also add to our structure, we're going to need a fragment file path as well. Then we can go back to our engine and specify the file path. Is fragment.spv. I want to make sure we don't get that wrong. I don't want to have some weird error come up again. Okay, great. So that's looking good. Now back to the show. Okay, that is looking good. So we just modify the code. It works pretty similarly. We will also need to destroy the fragment shader after it's been created. And then the other exciting bit is now that both shaders have been created, we can pass their info along to the pipeline. Okay, great. So after the fragment shader, we have multisampling. There we have it. So we're going to do no multisampling. We achieve that by disabling sampling shading and setting the rasterization samples to 1 sample. Okay, great. And I swear we're getting there. We're getting there. There's just a lot of stuff. And the next bit is color blend. So kind of like alpha, transparency, and the like. Okay, great. So little verbose said a lot of things, and the purpose of setting all those things was essentially to do no blending, but it is set up. So these are the kind of core components of a graphics pipeline, which, as you know, I went through in the last video. There are two other components that we need. That is the pipeline layout, which specifies the push constants and descriptor sets which will be used, uniforms basically, and then there's the render pass, which specifies the attachments. So let's make two helper functions, but we'll start with the pipeline layout. So we'll head back up. Alrighty, no worries. So it's going to be pretty simple at the moment, but I put this in its own function because in future we might want to have more control over that and not swim through that swamp of code that we just wrote. Okay, well, to a certain extent, if you're writing Vulkan, you're always going to be swimming through a swamp of code, but let's try keep it no more complicated than necessary. So there we have it. Nothing at the moment. Just as a refresher, a push constant is kind of like a uniform, but it can only handle a small amount of data, like one or two matrices. A set, descriptor set, is capable of holding sort of arbitrarily more resources. So we can pass in images, we can pass in whatever we want. Okay, so we've got that there. That's looking great. We can go down and use that. There we go. Okay. Great. So then the next step is we have the render pass. So again, we'll construct a general function to make a render pass because later on we might want to jump in here and alter things. So to create a render pass, we're going to need to describe what sort of resources are bound in the color buffer. We're going to need to know what the pixel format is for our swap chain. That's okay, we can specify that in our structure. And then we can go over to our engine and pass that info in. And that is all good. So we're going to know which sort of pixels we're binding in our color buffer. Okay. Okay, so we have described a color attachment Really critically, these load and store operations. So load operation is what do we do with the color buffer when we get it loaded to us, ready to render to it. Of course, we flush it out, we clear it with our clear color. When we write a pixel, do we store that pixel? Yes, we do. And what do we do to the stencil to the stencil buffer in these operations? Nothing at all. As well as the layouts. Now, the kind of confusing thing is now that we've described this, we need to create a attachment reference. Now, the analogy I would use here is when we're creating a frame buffer in OpenGL, if you're used to that, the first thing you do is you describe the buffer, and then you say, attach this as color buffer 0, attach this as something, something, something. That is essentially what we'll be doing here. We'll be saying, hey, when we use this, this color attachment will be attachment number 0. Okay, so this is describing sort of a reference to the act of attaching, is where is it being attached, and so on. Then we have the subpass. So remember, the subpass are all the substeps of a render pass, and we always have at least one. Okay, great. So we've got our subpass, and the next step is, finally, we'll describe our full render pass. Okay, there we have it. So note that the subpass is specifying the sort of signature of the attachments, whereas the render pass is actually specifying a more in-depth description of the underlying attachments. Okay, we can then use the device to create the render pass. Okay, I'm pretty happy with that. So we are creating and returning the render pass. We can close that function, and then we can finish off our pipeline creation. So we do all of these stages, and then we do the layout, and finally, well, not finally, we've still got a little bit more to go, but anyway, we'll go make the render pass. So we make that, and there's something I missed above. We've created the layout, but we also need to register that. So we'll go pipeline info. Okay, great. And now that we've made the render pass, we will specify that as well. Now, there's one more flag that we need to set. That is the base pipeline handle. So in order to speed things up, we can sort of have a pointer to a base pipeline, which we sort of work from. We're not going to do that. So now I'll make the pipeline. So the first argument here is a pipeline cache. And what that is we can store general pipeline info to speed up, like if we need to create a whole bunch of pipelines. We're not going to use that right now. We're just going to create one. But we will need to pass in the pipeline info. And that should be fine. But we have a complaint here. And the complaint is that this is returning... let me just do this. Yeah, so it says it's sort of returning a VK result value. So this is sort of like unwrapping. We'll just take the value from that. Great, so we should at least spell it right. So the graphics pipeline has been created, or not, who knows. So what I then want to do is bundle everything together and output it. So what do we have? We're going to have a pipeline layout, a render pass, and a pipeline itself. We can set those in the struct down below. And then that will be sent back. Okay, now let's go to the engine.h. We'll go to those pipeline related variables, and now we can fill those in. We can actually just grab them from the struct up above. And then in the source file, we can unpack them. Now, where are we? Okay, haven't run this in a while, so let's have moment of truth. Oh. Okay, what's going on here? No entry point found named name. That is, that's a problem. Yeah, okay, got it, because we are passing in the Vertex file path for the Fragment shader. So it's saying, hey, we don't have a Fragment shader with a main. Okay. Let's see if this fixes it. I should have been running that as I went. Okay. Right, so we've created everything, goodbye, see you, and then it's complaining that the objects have not been destroyed. Yep, that makes sense. So let's go to the cleanup function, and we'll just sort of do these in, any order at all. So goodbye, see you, and then we'll go. Okay, so now we're destroying them. Let's give that a go. And there we have it. We've run it. We've created everything. We're seeing no errors. It's excellent. All right. So again, in this video, we sort of ran through all the details of coding up a graphics pipeline, a basic graphics pipeline creation. Anyway, hope you enjoyed. Hope that sort of cemented the topic for the content from the previous video. And yeah, I'll see you again soon. Bye.